Hello, you guys. So let's just get into it today. We are in week 11 and we're doing November the 9th. Now, so what you see here are all the things that are open. All right. And so convection connection is a puzzle assignment. For what I've been told, it is not working. So for today, I'm going to say don't worry about doing it. If you are not in class today, then you're going to need to click on this Nearpod student pace heat transfer, which means you can go at your own pace while you are doing this. So, of course, you would type in your name. It's showing my name, but you would type in your name, hit join lesson, and then we're going to talk about the first type of heat transfer, which is convection. And so here's just a little information about the person who curated this particular Nearpod. These are the student objectives. So the objectives today, students will understand what heat transfer is. Students will understand how heat is transferred through convection. Students will understand how heat is transferred through convection currents in the Earth's atmosphere. So the first thing you guys have is the open-ended question where you guys, answer the question. How do you think heat moves through Earth's atmosphere? So if you're doing this by yourself, just answer the question the best you can. I just want to know what you think and submit it by hitting this button here. Next, I want you guys to write in your notebook these three things. First, I want you to write down the question. What is heat transfer? And then you're going to write number one in your science journal. Heat transfer is the transfer of heat from one object to another object. The second thing you're going to write in your notebook is heat can be transferred through radiation, conduction, and convection. And thirdly, heat is always transferred from the warmer object to the cooler object. So these three things you guys need to write in your science notebook. On this page, you guys need to write down what is convection. So number one, you're going to write down convection is the transfer of heat by movement of fluid. And then you're going to write down fluids can be liquids or gases. And then we're going to watch a short video. So let's watch the video. Now, I'm going to skip through the video. You guys can watch the video at home. Once you guys watch the video, you're then going to be asked this question: how is heat transferred in a pot of boiling water? So just think about the things you saw in the video, okay? So when you're thinking about this, or when you get ready to answer this question, because basically it's going to ask you what you and your partner discuss, but you're at home, so you may not have a partner. If you're discussing it with a brother, sister, a mother, father, or cousin, or whoever may be helping you, then you can write down what you guys saw in the video. But if you're watching the video by yourself, just write down what you saw in the video. How did it look like the heat was being transferred? So what we have here is this shows the heat being transferred. And so they got steps. So step one, it says when the water at the bottom of the pot gets heated, the water becomes warmer, less dense, and rises. So this is step one. Step one is the pot getting heated, okay? And so as it relates to this, as step one happens, again, because the molecules are getting less dense, they're starting to rise. So once they rise to the top, which is step two. Once they reach step two, again, at the top of the pot is cool up there. So because it is cool there, the water then is going to sink. And the water is going to sink back down because the molecules are more dense, or the water becomes more dense. So here are the steps again. One, it heats up, becomes more dense. I'm sorry, it heats up and becomes less dense and rise. It rises to the top. At the top, it's cooler. And so because it's cooler, the water comes back down and it is more dense and sinks into the pot. And so this rise of warm water in the pot and the sinking of cooler water creates convection currents. And so with convection currents, it's just the same thing we talked about with the pot. The water, it heats up. When it heats, it rises. When it rises, get to the top, it gets back cooler, or that cooler air. The molecules become more dense, and so they sink back down. And so it's just a continuous cycle over and over and over again. The heat rises because there's less more because the molecules are less dense, and then they sink back down because the molecules become more dense. So of course you would have this open-ended question to answer. Why do you think the warmer water at the bottom of why do you think the warmer water at the bottom of the top rises to the top? So why do you think it rises, and then why does it basically sink again? Now, this same type of convection current occurs in the Earth's atmosphere. Heat is transferred in the atmosphere mainly through convection. Now, remember, convection is heat that is transferred through liquids and gases. So let's see how this relates to Earth. So we're going to watch a short video with Bill Nye, the science guy. He's going to use to show convection. So you guys will watch this video here. So let's just watch it.
Bill Nye, the science guy. Bill Nye, the science guy. Bill Nye, the science guy.
Wind all over the world is caused by heating and cooling of the earth. Wind can do work. Hey, look at that. And it makes sailboats go! Wow, he went right through the door. Hey! Thanks, guys. Thanks. Whew. Now, real wind doesn't come from a fan. No, in nature, wind is caused by the heat from the sun and the rotation of the earth. That's what makes these intricate patterns of clouds that we see on this photo from space. It works something like this. This is our great big plastic wind box of science. These lights represent the sun. This ice represents the north and south poles. So here's what happens. Energy from the sun heats the land, and the land warms the air over the land. The air molecules get going faster, and they spread farther apart, so they don't weigh as much for the room they take up. So cold air can push the warm air up. That's why we say warm air rises. So look what's happening. The smoke shows us that the air is sinking over the cold poles, flowing over the cities, and then rising over the warm parts. See, it goes around in a great big circle. And that's what happens on the Earth. Now, there's one more thing. The Earth is spinning, so the wind starts spinning. That's why wind comes from all different directions. Wind is wild.
Bill Nye, the science guy.
Okay, so we learned a little bit from Bill Nye, the science guy. So on this right here, you guys would fill in the blanks just based upon what you guys heard Bill Nye, the science guy. If you need to go back and rewatch the video, you are welcome to do so. But this is just a fill in the blank just to check for understanding. Again, you guys can go back and watch the video and go from there. Here, you're just going to draw a picture of what happens doing convection. You're going to draw a picture of what happens doing convection. And then it's your quiz time. So hopefully you guys have been listening and paying attention to myself and Bill Nye, the science guy. And remember, this week, the Nearpods will be a lesson. So if you guys are listening and you're participating, remember, I'm going to take the participation grade or either the quiz grade, depending on which one you do the best on. Participation comes when you're answering all the different questions within the activity and you're completing your quiz. That's what a participation grade comes in at. So if that's it, if you have any questions, feel free to send me a message. And that is it on Convection Currents.